आज एक नई चीज़ बताने आए हैं, और नई चीज़ की शुरुआत कुछ ऐसे होती है कि जब इस दुनिया की शुरुआत हुई, ठीक है, इस दुनिया की शुरुआत में कहा जाता है कि सबसे पहले एटम्स आए। बाद में पता चला कि उनके सब एटॉमिक पार्टिकल्स, प्रोटॉन्स, न्यूट्रॉन्स और इलेक्ट्रॉन्स होते हैं, पर बचपन से और जो पुराने महर्षि लोग थे वो ये जानते थे कि एटम नाम की चीज़ होती है। और एटम जब एक से मिले तो एलिमेंट बने, एटम डिफरेंट डिफरेंट मिले तो कंपाउंड बने। मतलब एक प्योर चीज़ में एलिमेंट और कंपाउंड नाम की दो चीज़ें आ गई। एलिमेंट को पीरियडिक टेबल में सजा दिया गया, और कंपाउंड नाम पे डिस्कशन चालू हो गए कि ये कंपाउंड क्या होता है, ये कंपाउंड क्या होता है, ये कंपाउंड क्या होता है। अंत में ब्रॉडली उनको 3 कैटेगरीज में डिवाइड किया गया, जिसको बोला गया एसिड, बेस और सॉल्ट। अब एसिड क्या हुआ, कहते हैं लोग कि एसिड का मतलब है कि जिसमें H+ हो, एसिड का मतलब है ये, एसिड का मतलब है वो प्रॉपर्टीज में हम समझ आता है। जब बेसिस की बात आती है तो हम कहते हैं कि ऐसी चीज़ जो एसिड के इफेक्ट को खत्म कर दे वो बेस है। और क्या करके खत्म कर दे कि पानी बना के खत्म कर दे। और पानी बनने के लिए H+ को क्या चाहिए, OH-। तो फिर कह दिया गया कि बेस में OH- होना चाहिए। सॉल्ट की जहाँ बात आई तो कहा क्या गया कि ना तो एसिड बचेगा ना बेस बचेगा, तो क्या बचेगा, सॉल्ट बनाओ, पानी बचेगा। सॉल्ट मतलब एक आयनिक कंपाउंड जिसमें कैटायन और एक एनायन। ये सारी चीज़ें ब्रॉडली कैसे एक दूसरे के साथ बात करेंगी, कैसे एक दूसरे के साथ डिफरेंशिएट होंगी, और कैसे एज एन पूरे वर्ल्ड एसिड बेस सॉल्ट का वर्ल्ड जो है उसमें डिफरेंट डिफरेंट फीचर्स को अपने अपने टाइप से बताने की कोशिश करेंगी। तो ये कुछ इंपॉर्टेंट टॉपिक्स लिए हमने इस टॉपिक के, और वो बच्चे बताने की कोशिश करेंगे। ठीक है, तो देखते हैं।
Hi, Sanushri to tell you about litmus olfactory indicators and acids. Indicators are the substances which indicates that whether the substance is acid or base. Litmus is a natural indicator which is extracted from a plant named lichen, and it's a division of Thalophata, and it is a purple dye which as acids turns blue litmus to red and bases turns red litmus to blue. The substances which changes their smell in acids and bases are known as olfactory. The indicators which indicates the acids and bases by changing their smell is known as olfactory indicators. Example: vanilla essence or onion. Now acids. The substances which releases H+ ions when dissolved in water is known as acids. They are sour in taste and turns blue litmus to red. We can commonly find acids in fruits like lemon, orange, mango, etc. Acids are of 2 types: mineral acid and organic acids. Mineral acids are the acids which we find from minerals present in earth. They are strong acids like hydrochloric acid, nitric acid and sulfuric acid. Strong acids means they dissociate completely into ions when dissolved in water. Now organic acids. Organic acids are the acids which we find from plants and animals. They are weak acids like citric acid, which we can find in fruits like lemon and orange. Oxalic acid, which we can find in tomatoes. They are weak acid means they partially dissociates into ions when dissolved in water. Now properties of acids. Physical properties. They are sour in taste. They conduct electricity when dissolved in water. As on mixing with water, they dissociate into ions. They dissociate into free ions. Now they turn blue litmus red, and they are highly corrosive in nature. Now the chemical properties of acids. Acids when reacts with metal, they give salt plus hydrogen. Like when HCl reacts with sodium, it gives sodium chloride and hydrogen, and here sodium chloride is salt. Now second, when acids react with metallic carbonates, they give salt, carbon dioxide and water. When HCl reacts with sodium carbonate, it gives NaCl plus carbon dioxide and water. Now when acids reacts with metallic hydrogen carbonate, they give salt, carbon dioxide and water. HCl reacts with the sodium hydrogen carbonate, it gives NaCl plus carbon dioxide and water. When acids react with metallic oxides, they give salt plus water. When HCl reacts with sodium oxide, it gives NaCl plus water. When acids react with bases, it gives salt plus water. When HCl reacts with sodium hydroxide, it gives NaCl plus water.
This is Harsha standing before you.
Pause.
Standing before you to tell you on the topic base. Bases are chemical substances that have a bitter taste. Base turns red litmus to blue litmus. Base are totally opposite to acid. For example, NaOH, CaO, CaOH whole twice. A base which is soluble in water is called alkaline. Now, do you know what all bases have in common? The common thing that all bases have is that they produce hydroxide ion when dissolved in water. For example, NaOH. When NaOH is dissolved in water, it produces Na plus ions and OH minus ions. Now, we move on to the properties of bases. First, the base is it turns red litmus to blue litmus. Third, it conducts electricity. And fourth, when base reacts with metal, it produces the salt and hydrogen. For example,
ये मुझे भी करता है वो तो इसके लिए भी एक ट्रेनिंग है.
when zinc reacts with sodium hydroxide, it forms sodium zincate plus hydrogen. Second comes the when base reacts with acid, it gives salt and water, which is a neutralization reactions. For example, when sodium hydroxide reacts with sulfuric acid, it gives sodium sulfate plus water. The next comes when base reacts with non-metal oxide, it gives salt and water. For example, when calcium hydroxide reacts with non-metal oxide, that is carbon dioxide, it forms calcium carbonate plus H2O. From this reaction, we got to know that the non-metal oxides are acidic in nature. Now, the bases are of two types, strong bases and weak bases. Strong bases are those bases which completely ionize when dissolved in water and produces a large amount of hydroxide ion. Second is the weak base. Weak base is the base which partially ionized when dissolved in water and produces a small amount of hydroxide ion. Thank you.
Hello, I am Nidhi Goswami and today I am going to tell you about pH scale and universal indicator. In 1909, Sorensen devised a scale on which strength of acid and acidic and basic solutions. In 1909, Sorensen devised a scale on which strength of acidic as well as basic solutions can be represented by making the use of hydrogen ion concentration. So, the strength of acids and bases can be measured on a scale of numbers called pH scale. In pH, P stands for potence, which is a German word for power, and H stands for hydrogen ion concentration. pH scale has values from 0 to 14. Since pH is a pure number, it has no units. pH of a solution is inversely proportional. Solution is inversely proportional to the concentration of hydrogen ion. For example, the hydrochloric acid have a pH of 0, so it is a strong acid, whereas citric acid have a pH of 4, so it is a weak acid. Neutral substances have a pH of exactly 7. For example, water and sugar solutions have a pH of 7. Acids have a pH of less than 7, bases have a pH of more than 7. For example, sodium hydroxide is a strong base which have a pH of 14, and magnesium hydroxide is a weak base which have a pH of 8. Now we will move on to universal indicator. Universal indicator is a mixture of many different indicators which shows different colors at different pH values. This cannot tell us the relative strength of acids or base, so thus to obtain an idea how acidic or basic a substance is, universal indicator is used. When we put a drop of solution on universal indicator, it produces a color. The color produced is used to find the pH value of acid or base. For example, if the universal indicator turns dark red, then it will be a strong acid. For example, hydrochloric acid, universal indicator turns green on the pH of 7. So water and sugar solutions will turn universal indicator green. In fact, pH plays an important role in our everyday activities. pH in our digestive system is important for the process of digestion. The pH changes in our mouth can cause tooth decay. The proper maintenance of pH is important for the growth of plants and survival of animals. And some plants and animals use acidic as well as basic liquids for self-defense purposes. Thank you.
Is sodium carbonate with 10 molecules of water, and its formula is Na2CO3.10H2O. Now we move on to its preparation. First we will take cold and concentrated solution of sodium chloride, which will be mixed with ammonia, water and carbon dioxide, which will form sodium hydrogen carbonate. This sodium hydrogen carbonate we will take in next step, and which will be separated by filtration, dried and heated. On heating, it will decompose sodium carbonate plus water. Which is also known as soda ash, as it is anhydrous sodium carbonate. Now this sodium carbonate in the third and the last step will be dissolved with 10 molecules of water, which will be recrystallized to form washing soda. It is also known as sodium carbonate decahydrate. So we have made washing soda, and now we move on to plaster of Paris. On to plaster of Paris, which is calcium sulfate hemihydrate, and its formula is CaSO4.12H2O. Now we move on its preparation. This is gypsum, which will be heated at 373 degree Kelvin or 100 degree Celsius. Which will form CaSO4.12H2O plus 1.5 H2O. This is plaster of Paris, but this reaction is only chemically proven, but it cannot be led out in laboratory. So laboratory reaction is, we will take gypsum, which will be again heated at 100 degrees Celsius or 373 degree Kelvin. And which will form plaster of Paris plus 3 molecules of water. Now if we want gypsum back from plaster of Paris, we will mix water in plaster of Paris, that is CaSO4.12H2O plus 1.5 H2O, which gives us gypsum, that is CaSO4.2H2O. So we made washing soda and plaster of Paris in the above discussion. Thank you.
The baking soda. The chemical name of baking soda is Now comes the baking soda. The chemical name of baking soda is sodium hydrogen carbonate.
Pause.
Comes the baking soda. The chemical name of baking soda is sodium hydrogen carbonate. It can be represented as NaHCO3, which is also known as sodium bicarbonate. Now we move to the preparation of NaHCO3. Till now we have seen the formation of washing soda. The first step of the formation of washing soda is itself the formation of baking soda. It can be prepared as the reaction of cold and concentrated NaCl with NH3, carbon dioxide and water.
Full stop and pause.
Cold and concentrated solution of NaCl reacts with ammonia and carbon dioxide to form NaHCO3, which is sodium bicarbonate, as well as NH4Cl. Now we move on to bleaching powder.
Pause.
The chemical name of bleaching powder is calcium oxychloride, whose chemical formula is CaOCl2. Now we will move to the preparation of calcium oxychloride. When chlorine is passed through calcium hydroxide, that is slaked lime, calcium oxychloride and water is formed.
Pause.
Move on to water of crystallization. The fixed number of water molecules which are present in one formula unit of salt are called water of crystallization. The salts which contains water of crystallization are called hydrated salts. For example, copper sulfate got 5H2O, that is, it containing 5 molecules of water of crystallization, so it is called copper sulfate pentahydrated. Washing soda crystals containing 10 molecules of water of crystallization, that is sodium carbonate dot 10H2O. It is called sodium carbonate decahydrated. Next is calcium sulfate. Calcium sulfate containing 2 molecules of water of crystallization. They are also known as gypsum crystals. The water of crystallization present in the salt are the crystal structures of the salt. They do not wet the salt because this is not the free water. When the salts, hydrated salts are heated, they lose their water of crystallization. The salts which do not have water of crystallization are known as anhydrous salt. Water of crystallization gives salt their color and shape. For example, when copper sulfate containing 5 molecules of water of crystallization is heated, it decomposes into copper sulfate and gives 5 molecules of water. Copper sulfate pentahydrated is blue in color, but when it is heated, then copper sulfate is white in color and it loses its 5 molecules of water.